Hi everybody, this crazy physics question is for you. A car moves rectilinearly first with acceleration w equal to 5 meter per second. Initial velocity is 0 and then uniformly and then finally deaccelerating with same rate w and then comes to rest. The total time during motion is t0 equal to 25 seconds. The average velocity during motion is 72 km per hour. The question is how long does a car moves uniformly? I got this question from the book Problem in General Physics written by I.E. Irodov and it is problem 1.3. Please give your try to this question and keep watching for the solution. Now for the solution, first we need to imagine the condition that is given in our question. So here is our road and here is a car. First the car moves uniformly acceleration with w equal to 5 meter per second and then with uniform velocity v, that is our final velocity during acceleration w, and then finally it deaccelerates with same rate w and then comes to rest. And there is a more information during this motion, that is total time during motion equal to t0 equal to 25 seconds and the average velocity equal to 72 km per hour. So we can erase it and let the time during w acceleration equal to t1 and then same with uniform velocity be t2 and then time during deacceleration be t3 and let the distance during t1 time equal to st1 and same let the distance during t2 time equal to st2 and let the distance during time t3 equal to s33. Now we can merge that all. We know that average velocity is equal to total distance divided by total time. So here average velocity is equal to 70 km per hour, that is equal to total distance let be s divided by total time that is given is t0, and 72 km per hour is equal to 20 meter per second, so 20 is equal to s by 25. So the total distance during motion is equal to 500 meters. So we write in the corner. Now we use the Newton's equation v square is equals to u square plus 2as in the case of acceleration. So v square is equals to 0 square because our final initial velocity is equal to 0 plus 2 times acceleration times st1. So v square is equal to 10 times st1. So v square by 10 is equal to st1. So now we can use this equation also in deacceleration part. So 0 square because our final velocity is 0 equal to v square because uniform velocity is v plus 2 times negative 5 times st3. So negative v square is equals to negative 10 s t3. So v square by 10 is equal to s t3 and it is exactly equal to the distance during t1 time. So s t1 is equal to s t3 equal to v square by 10 and we write here it in the side. Now the distance during part of acceleration and the distance during part of the deacceleration is same and their rate of acceleration is also same, so we can say that time t1 is equal to time t3. Now we have enough information to find our time during uniform velocity. So now we can erase that all and write all the information corner that we find. Now we know that time is equal to distance over speed. So t2 is equals to s t2 by v. So t is equal to 500 minus as t1 plus as t3. So T2 is equals to 500 minus 2 times V square by 10, because we can find that as T1 is equals to as T3, that is equals to V square by 10. So now we can simplify that. We know that V is equals to U plus AT. So V is equal to 0, because in our first case V initial velocity is equal to 0 plus acceleration, that is equals to our 5 times t1. So V is equal to 5t1. So now we write in the corner and then use in the substitution of t2. So T2 is equals to 500 minus 50 T1 square by 10 over by 5 T1, and we simplify that. So we get this quadratic equation where T1 work as a variable x. Now we use the quadratic formula, that is x equal to negative b plus or minus the square root of b square minus 4ac over 2a, and here t1 work as x, so t1 is equals to negative t2 plus or minus the square root of t2 square minus 4 times 1 times negative 100 over 2 times 1. So 2t2 is equal to negative t2 plus or minus square root of t2 square plus 400. So whole square of t21 plus t2 is equal to square root of the t2 square plus 400, and now square got cancelled by square root, and we know that t1 is equals to t3, so we can write 2t1 is equals to t1 plus t3. So t1 plus t3 plus t2 whole square is equals to t2 square plus 400, and t1 plus t2 plus t3 is the total time during motion that is given us, that is equals to t0, which is equals to 25 seconds. So 25 seconds square is equals to t2 square plus 400. So 25 square is equals to 625, minus 400 is equal to t2 square, and now t2 square is equals to 15 seconds, and that is our correct answer. Thanks for watching your maths and physics guy. Please subscribe my channel, like my videos and share it. You can also send me questions on email. My email ID is mathguy192005